friends, my name is Tushar and today I'm going to talk about how to find lowest common ancestor in a binary search tree. So you're given a binary search tree and you're given two nodes and you have to find what is the lowest common ancestor of those two nodes. For example, if my two nodes are 28 and 78, so 28 and 78, then the lowest common ancestor will be 30. Another example, if my two nodes are 6 and 30, so 6 and 30, then the lowest common ancestor would be 10. And last example, if my nodes are 30 and 78, then the lowest common ancestor in this case is 30. So basically we are looking for a node from which the two nodes which we are looking for diverged in different paths. And if one node is an ancestor of the other node, then that node is also lowest common ancestor of the two nodes, as it is, as we see with the example 30 and 78. In this case, 30 is a binary is the lowest common ancestor. Next, let's see how we solve this. One assumption here is that all the nodes are unique in the binary search tree. So since it's a binary search tree, we know that every node on the left side is less than the root node, every node on the right side is greater than the root node, and this is recursively true for every node. So the algorithm is as follows. You start from the root node, you check if root node is greater than both the nodes whose lowest common ancestor we're looking for, then we go on the left side. If it is less than both the nodes whose lowest common ancestor we're looking for, then we go on the right side. Otherwise, that node is the lowest common ancestor. So let's take some examples. So 20 and 78, we are looking for the lowest common ancestor of 20 and 78. So we start from 10. 10 is less than both 20 and 78, which means that we move on the right side, because all the keys greater than 10 are on the right side. So we reach 30. 30 is less than 28, is greater than 28 and is less than 78, which means that 30 is the lowest common ancestor for these two nodes. Let's take another example, 6 and 9. So we start from 10. 10 is less than 10 is greater than both 6 and 9, so we move on the left side. Minus 10 is less than both 6 and 9, so we move on the right side. 8 is greater than 6, less than 9, so 8 is the lowest common ancestor here. Let's take another last example, 30 and 78. So we start from 10. 10 is less than both 30 and 78, so we move on the right side. On right side, 30 is same as this 30, which means that we found the lowest common ancestor, and then we return 30 in that example. So as you can see, algorithm is extremely simple. So the runtime complexity for this algorithm will be O of h, where h is the height of the binary search tree. Next, let's look at the code for this algorithm. The code is extremely straightforward. The function name is LCA lowest common ancestor. This is the root of the binary search tree, and these are the two nodes whose lowest common ancestor we are looking for, and we return the lowest common ancestor. So with the first if condition, we check if root is greater than the max of n1 data and n2 data. So if root is greater than max of n1 data and n2 data, it means that it's greater than both, which means that we move on the left side, because the lowest common ancestor should be on the left side. So we say return LCA root.left n1 and n2. Else if root is less than the minimum of n1 data and n2 data, which means that root is less than both the guys, since it's less than the minimum of the two guys. In that case, we move on the right side, so we say return LCA root.right n1 and n2. In the third condition, if none of these two conditions satisfies, then root is the lowest common ancestor, and then we return root. So this is all I have to talk about lowest common ancestor in binary search tree. Please like this video, share this video, comment on this video, check out my Facebook page, and check out my GitHub link. Thanks again for watching this video.